Hello and welcome back to my channel. I look a bit naked. I'm just going to move that. Okay, I do have clothes on. So I'm going to talk to you today about the difference between Java heap space and stack memory. So if you're unsure about stacks, please go back and watch the data structures video. I have a playlist on data structures that I plan to add to, and I'm really happy that one of my students today asked me the difference because I love bringing out my plates. Here we go to explain our stacks. So I explain this in terms of memory method for a method called stack, and I think that's the easiest to think of it. So I have my dinner. I put it on my plate. Here it is. I have to push on, and when it's all done and everything's finished, then I pop it off. Okay? So I push on, pop off, like that. And that's called our stack. So in a really simple form, we already know something about method call stacks because I spoke about a method as being something that a task an employee does. We have our employee then goes to their department. They can ask multiple other people to do different tasks. So they call different methods, and then they come back with the result, and that's our return, which is our return address. And once we have the return address, then that memory, so I said in the previous video, goes away, but the official way to say it is that it's out of scope. So it goes out of scope of the memory of the program even. So another way to look at that then is a stack is also going to be part of other memory. So we have stack is used for static memory location, SS. Okay, and then a heap is used for dynamic memory allocation, and both are in the computer's random access memory, so our RAM. So the reason why we have things like objects going to be stored in a heap is because we don't know the size of an object. So when we create a string object, then we can allocate a different size. We have methods associated with it, and how we identify a string being a reference type object in our program. If you're unsure, please go back and check. But it's a capital letter for a string for the variable when we type string on the program. It's not a lowercase like a primitive type, which is a I, lower letter I for int, or lower letter B for byte. And so we also have that's our string, and then when we call whatever, allocate our box in memory for a string, and whatever we call it, let's say we're going to call it string A. So string A, and when you put a dot, use the dot operator, a whole list of methods come up alongside it, and that is our reference type. But for an integer, if I was to have an integer box and put something in it and call it x, if I was to say x and put my dot operator beside it, no memory, no methods come up, and that's one of the ways to identify it. So with heap memory then, heap memory is used to call all the different parts of an application, whereas a stack memory is only used within one thread of execution. So that would be the same as what I just said about a method. So we have our method, we use the method, it returns with the return address, it's now gone, that's it. So everything that was used within that method is now gone. Gonzo. Okay, then we have whenever an object is created, it's always stored in our heap space. And stack memory contains the reference to it. So we have a reference in our stack to the heap memory, but it's dynamically allocated. So our stack memory only contains then our local very primitive variables. So our int, our byte, our bools, all of the primitive variables which are identified with a lowercase letter. And this is why we use good naming conventions and good standards within Java, so you can identify it when you're actually allocating your own local variables as well. So stack memory only contains local primitive variables and references to the objects in the heap space. Objects stored in the heap are globally accessible. Stack memory can't be accessed by other threads. Okay, so they're limited. They go out of scope. They're not there anymore. I have my stack here. My dinner is now eaten. I pushed it on and I popped it off, and that's it. Okay, it's gone. It's your last in, first out data structure. Then we have objects stored are obviously going to be globally accessible. Memory management in stack is done with the last in, first out. So when we pop it off, it's gone. So heap memory then is divided into different like young generation, old generation, and garbage collection. But as we know with Java, it's automatic garbage collection. If you're unsure about garbage collection, please check out my garbage collection video. And then stack memory is short-lived, whereas heap memory lives from the start till the end of the application execution, which we know already because when we have a method, when we use the method or whatever, then it's done. Okay, that's a really short explanation of stack and heap. If you'd like to learn more about these memory allocations, please subscribe to my channel or ask me a question in the comments below. The other impact of using heap space and stack memory then is obviously the impact you have on hardware, and I'm hoping to do more videos on hardware and the impact we use as developers when we're typing out and why we're using primitive types versus reference types in certain ways, because we already know that we can box our primitive type into a reference type and then use it in that way and use string representations and etc, 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 and why we use one and not the other. And there's also the Stack Overflow and these kind of things as well. But for now, all we need to know is we have our stack memory here, our heap memory here. One is dynamic, one is static. Dynamic means that it can change, it's changeable size-wise. Let's say we have a string, and then our stack memory then uses a reference to, so they both communicate with each other. So as soon as we run the program, it loads the runtime classes into the heap space, and then we use the main method, which is found in every one of our Java classes, which we know, public static void main. It's used to identify the first line, and then Java runtime creates the stack memory to be used by main method thread. That is why in the videos that I'm talking about, I always say this is the main thread. Okay, main thread of execution. We are creating primitive local variables then, and once we create the primitive local variables, they're created and stored in the stack memory of the main method. Then when you're obviously finished with that thread, they're gone. So I'll go into a little bit more detail in another video. I'm really happy I'm going to start on these kind of things, and please subscribe to keep the channel alive. Thanks, bye.